Hey there, focus learners, and welcome back to another explainer. Today, I'm definitely putting on my coach's whistle because we're going to demystify one of the most intimidating challenges in AP Computer Science, the Create Performance Task rubric. And you know what? We're going to do it efficiently, clearly, and completely by dissecting just one single brilliant Python program. Let's get right into it.
Okay, let's dive right into our roadmap. We'll start with the function versus purpose trap. Then, we'll look at our sample program, the study streak tracker. After that, we hit the 4 rubric requirements, go inside the procedure itself, and finally, talk about passing the capstone. It's a straightforward, organized process.
Section 1. Function versus purpose. Let's talk about the #1 AP trap. Before we write a single line of code, listen to this quote straight from the Chief Reader Report. Students who write only the function description fail the purpose and function rubric row. Now that is a massive, flashing warning light. If you only describe what your code physically calculates, you are guaranteeing a failed rubric row right out of the gate.
Let's anchor the critical difference here. On one hand, we have the function. This is the literal computation. It's the raw, nuts and bolts mechanics of your code. On the other hand, we have the purpose. That's the user benefit. This is the why. Why does an actual human being want this tool in their daily life? You absolutely have to separate the machine's job from the human's goal. So, breaking that down a bit further, the function iterates records, filters for a subject studied for more than 30 minutes, and returns a streak. Pretty technical, right? But the purpose? That helps the student identify consistent studying, detect gaps before an exam, and adjust their schedule. So the crucial point here is that a full-point AP answer requires both of these distinct descriptions. You need the technical what and the human why.
Section 2. The Study Streak Tracker. This is our anatomical specimen.
Let's look at some raw input data for our tracker. We've got dates, subjects, and minutes studied. Now, what's really interesting here is that not every study session actually counts. Our tracker only rewards serious effort. According to the program's rules, only study sessions of 30 minutes or more actually count toward the streak. So, a quick 25-minute history session? Yeah, that isn't going to make the cut.
And for our final expected output, if we target math, we expect a 4-day streak, history gives us 1 day, and Spanish gives us 0 days. This is the ultimate goal of our compute streak function. It perfectly matches that purpose we defined earlier by giving the user actionable, real-world feedback about their study habits. Section 3. The 4 rubric requirements. Time for our mandatory checklist. Here is your non-negotiable checklist. Step 1. Input. Step 2. A list used for complexity management. Step 3, a parameterized procedure. And Step 4, output. I really want to remind you right now, missing even one of these structural components is a critical error. So let's see exactly how our tracker handles them.
Let's quickly dispense with the easiest ones first, the input and output requirements. Input simply enters our program via append calls, adding records to our dataset. Output is just the final streak count printed directly to the screen for the user. Boom! 2 rubric points easily satisfied, just like that.
Moving on to requirement number 2. Our tracker uses a list called study_records to hold all those dates and times. Why does this matter? Well, think about it. Without this list, you would literally need a separate variable for every single study day. Imagine typing out Math Day 1, Math Day 2, Math Day 100. It'd be a total nightmare. This list is your literal ticket to earning that managing complexity point on the rubric.
Section 4. Inside the procedure. Let's focus our magnifying glass on the core logic.
First, let's establish a formal definition. What exactly is a parameterized procedure? It's a student-developed procedure with arguments mapping to parameters that returns a value back to the caller. In our tracker, our compute streak function specifically takes records and target_subject as its crucial parameters. This design is what allows the code to be reusable for literally any subject the user wants to test.
But the rubric demands more. Inside that procedure, you absolutely must include a mini checklist of 3 key things. Sequencing, which is line-by-line execution, selection, which means if-else conditionals, and iteration, which means loops. These 3 elements combined are the non-negotiable engines of algorithmic efficiency. Let's look at iteration first. Notice the for record in records and for I in range code looping through our dates. Walking through those deduplicated dates one by one is exactly how the tracker satisfies the iteration requirement. It's systematically checking every single piece of data provided. Next up is selection. We have an if statement that says,
if subject equals target subject, and minutes are greater than or equal to 30, and this brilliantly illustrates how selection acts as the strict gatekeeper. It evaluates the data and only lets valid 30-minute study sessions pass through to be counted towards the streak.
Finally, sequencing. Notice how the command to append the qualifying dates sits directly following the selection condition we just talked about. The precise order of these lines, the sequencing, is what makes the algorithm logically sound. If you appended the date before checking the 30-minute condition, your streak logic would be completely ruined. Order matters, for sure.
Section 5. Passing the capstone. Let's synthesize our success.
I want you to keep one specific number in your head right now. 1. It takes exactly one concise program to fulfill every single complex requirement of the AP Create PT rubric. You really don't need a massive, sprawling, 1,000-line application. You just need one well-structured, tightly coded piece of logic.
And that is exactly what we've built here. The study streak tracker is correct, it's completely reusable across different subjects, and it's 100% rubric compliant. Take a moment of validation right now, because you now have the core knowledge to conquer the artifact layer of Unit 9.5.
Before we wrap up this explainer, I want to leave you with a provocative challenge directly from the source material. Imagine a classmate confidently says to you, "My procedure is rubric compliant because it calls a for loop." What follow-up question must you ask to verify this? Think about it. Just having iteration isn't enough. You need to ask them, does your procedure also contain sequencing and selection to execute complex logic? If not, they aren't passing. Keep that combined power of sequencing, selection, and iteration in mind as you review your own code. Thanks for learning with me today, and keep focused on that rubric.